Good morning students, this is Latif sir. In this video today I am continuing the chapter 5 of class 9 chemistry. The topic is periodic table. In the last live class I have discussed up to different types of elements. Okay, so in the last live class I have discussed about periodicity in modern periodic table, main feature of modern periodic tables, and I have told how many groups are there in the modern periodic table and name of different groups. And how many periods are there. That is in modern periodic table total 18 groups and 7 periods, and in each period how many elements are there, and which period is known as shortest period, which period is known as longest period. Everything I have discussed in the last live class. Okay, and types of elements also. 4 types of element: representative, transition element, inert transition element, inert gases or noble gases. Okay, so up to this portion type of elements I have discussed in the last live class. Okay, now in this video I'll discuss about merit of modern periodic table. Merits of modern periodic table. I have told that the modern periodic table is based on atomic number. The basis of modern periodic table is atomic number. Okay, so the merit of modern periodic table, it is based on atomic number, which is an even better fundamental property compared to atomic mass. And second merit of modern periodic table is position of an element in the periodic table is related to its electronic configuration. In the modern periodic table, the position of an element is related to its electronic configuration. Okay, and third merit, it shows regular changes in properties of element moving across a period or down a group. In modern periodic table shows the regular variation in properties of elements on moving across a period or down a group. Now one note is given here: what is periodic properties and what is periodicity of element. There are some properties like atomic size or atomic radius, atomic size and metallic character, reducing character, oxidizing character, reactivity. So these properties that reappear at regular interval, or in which there is gradual variation, that is increase or decrease at regular interval, are called periodic properties. Okay, so properties that reappear at regular interval or in which there is a regular variation, that is increase or decrease at regular interval, are called periodic properties. Example of such periodic property I have told: atomic size, metallic character, non-metallic character, reducing character. Okay, these are some periodic properties. And the phenomenon is known as periodicity of element. Okay, which phenomena? These are the repetition of property at a regular interval is known as periodicity of element. And what is the cause of periodicity of element in modern periodic table? The cause of periodicity is recurrence of similar electronic configuration. After a certain interval. Okay, so the cause of periodicity is recurrence of similar electronic configuration. In a particular group, number of electrons, there are total 18 groups, and in each group number of electrons in the outermost orbit remain same. Okay, number of electrons in the outermost orbit in a particular group remain the same. That is, electronic configuration is similar. Electronic configuration of all the elements in a particular group is similar. outermost electronic configuration or valence shell electronic configuration is same for all the elements in a particular group. Therefore, valency of the element also remains same in a particular group. That's why the elements of same group have similar properties, because they have similar electronic configuration, outermost or valence shell electronic configuration. Now see defect of modern periodic table. There are some defect also. Defect of modern periodic table. First, position of hydrogen. It is one defect, position of hydrogen. Position of hydrogen in modern periodic table is still not satisfactory, as its properties relates to both group 1 and group 17. Okay, so position of hydrogen in modern periodic table is still not satisfactory. Okay, because hydrogen has similar properties with both group 1 and group 17 element. And next defect is it fails to accommodate the inner transition elements, that is lanthanide and actinide element, into the main body of the periodic table. The modern periodic table fails to accommodate the inner transition element, that is lanthanide and actinide elements, into the main body of the periodic table. These are two defects of modern periodic table. Now see general trends of the modern periodic table. General trends of the modern periodic table. So first, it is given that groups in group, you have to study about the different periodic properties across a group and down a group and across a period separately. Okay, so first in group, number of shell and valence electrons. Number of shell and valence electron. How number of shell and valence electron changes across a group? Number of shell increases arithmetically and number of valence electron remains same to the number of valence electron remains equal to the number of group to which the element belongs. In a particular group, number of shell increases down the group one by one, and number of valence electron remain equal to the number of group to which the element belongs. And you can see one more point is also the number of electrons in a given element, number of electron cell in a given element, which is a measure of period number. So number of cell in an element which is equal to the number of period to which it belongs. So in a particular element, the number of cell indicates group period number, and number of electron in the valence shell is known as is equal to the group number. Okay, so number of electron in the valence shell is which represent group number, and number of cell which represent the period number. For example, in group 17, fluorine, chlorine, bromine, iodine, astatine, number of cell in fluorine is 2, so it is second period element. Number of cell in chlorine is 3, so it is third period element. Number of cell in bromine is 4, so it is fourth period element. Number of electron in iodine is 5, so it is fifth period element. Number of electron in astatine is 6, so it is sixth period element. And now see electronic configuration. Fluorine atomic number is 9, so electronic configuration 2 and 7. In first cell 2 electron, in second cell 7 electron. And electronic configuration of chlorine, in first cell 2 electron, in second cell 8 electron, in third cell 7 electron. Okay, in bromine first cell 2 electron, in second cell 8 electron, in third cell 18 electron, and fourth cell 7 electron. So across down a group you can see that is total number of valence electron remains same in all elements. In all halogen elements the number of valence electron is 7. Okay, so down the group number of valence electron remains same. Okay, and number of valence electron which is equal to this cell number of that of this element. Number of electron in the valence shell which is equal to the group number of that element. And valency, how valency changes across a group. So valency of an element equal to the number of electron present in its valence shell. Valency of an element is equal to the number of electron present in its valence shell. Since the element in a particular group have an equal number of electron in their respective valence shell, valency of all the elements in a particular group is same. Valency of all the element in a particular group, valency of all the element in a particular group is same. So you can see in group 1 lithium, sodium, potassium, their valence shell contain only one electron, so their valency is 1. Okay, but if the number of electron in the valence shell is more than 4, okay, more than 4, then valency is equal to 8 minus or 18 minus number of electrons in the valence shell. Sorry, it is 8 minus number of electron in the valence shell. Okay, so valency is equal to number of electron in the valence shell. If the number of electron is 1 to 4 in the valence shell, then valency is equal to number of electron in the valence shell. But if number of electron in the valence shell is more than 4, then valency is equal to 8 minus number of electron in the valence shell. Now properties of elements like reactivity, chemical reactivity across a group. Chemical reactivity across a group, that is in any specific group, chemical reactivity increases down the group. Okay, for example, alkali metal group 1 elements, they are very reactive and reactivity increases down the group. That is, reactivity of lithium is less than reactivity of sodium, which is less than reactivity of potassium, which is less than reactivity of rubidium, which is less than reactivity of cesium. Okay, similarly in halogen, in case of halogen, down the group reactivity decreases. In case of alkali metal, reactivity increases down the group, but in case of halogen, reactivity decreases down the group. Okay, so for different group, reactivity order is different. In case of alkali metal, in case of alkaline earth metal, reactivity of element decreases down the group, and in case of halogen, reactivity is just opposite. In case of halogen, reactivity of halogen decreases down the group. Okay, so reactivity of different halogen decreases from fluorine to iodine. Fluorine is the most reactive element in group 17, and iodine is the least reactive element in group 17. Now see next physical periodic property, atomic size. Down the group, you know, atomic number of cell increases 1 by 1. Down the group, number of cell increases 1 by 1. Okay, so their atomic size is also increases. So in a particular group, atomic size increases from top to bottom. So for in group 1, lithium, sodium, rubidium, potassium, rubidium and cesium, down the group atomic size increases from lithium to cesium. Okay, metallic character down the group, metallic character increases. Okay, metallic character increases as we move down a group. Metallic character generally increases as we move down a group. Okay, so metallic character of group 1 element increases from lithium to cesium. Similarly, in group 17, metallic character increases from fluorine to iodine. Down the group metallic character increases. Okay, and now period uh, variation in periodic property from left to right in the modern periodic table. Number of cell remain same. Number of cell remain same on moving from left to right in a given period. Okay, number of cell remain same, but number of electrons increases one by one in a particular period from left to right. Okay, for example, in third period, sodium to argon, number of cell is same in all element of third period. Total three cell are there, but number of electron is increases. Number of electron increases one by one. Atomic number of sodium is 11, atomic number of magnesium is 12, atomic number of aluminium is 13. Okay, so number of electron is also increases one by one from left to right. And number of electron in the valence shell, also increases one by one from left to right. Okay, in the modern periodic table, from left to right in a particular or in a given period, number of electron in the valence shell increases one by one. And valency also first increases, then number of electron first increases then decreases. Okay, so you can see here valency with respect to hydrogen. First increases up to carbon, then valency of element in second period decreases from nitrogen to fluorine. Okay, so valency of element in a particular period, in a given period, first increases then decreases in terms of hydrogen. In terms of oxygen, valency of element increases from group 1 to group 17. Okay, and size of atom in a particular period, size of atom decreases from left to right. You can see, because number of cell remains same, but number of electron increases one by one, and number of positive charge in the nucleus also increases one by one. Okay, so number of so the atomic size or size of atom decreases from left to right in a particular period. And reactivity of element first decreases up to group 14 and then increases in a fixed period. Metallic character also, on moving from left to right in a given period, metallic character decreases. Metallic character decreases and non-metallic character increases. Okay, for example, in period 2, lithium and beryllium, these are metals, and boron is metalloid, and carbon, nitrogen, oxygen, fluorine, neon, these are non-metals. So from left to right, metallic character decreases and non-metallic character increases. Okay, so oxide of elements in a particular period become progressively less basic and finally changes into acidic character. And you have to remember, oxide of elements in a particular group, down the group, basic character of the oxide of the element in a particular group, down the group increases, basic character increases. Okay, and in a particular period from left to right, acidic character of oxide increases. And now see here some study of some groups, group 1, group 2, these are given. Next I will discuss this point. Okay, study of specific group, group 1, group 2, group 17 and group 18. Thank you, students.